Hello friends, welcome to Code Sutra. In this video, we'll be solving Leetcode problem number 2369. Check if there is a valid partition for the array. In this problem, we are given an array and we have to check if the array can be partitioned in a way all of the subarrays are actually good. So, what are the conditions for a subarray to be good? There are three conditions. The first condition, a subarray is considered to be good if it is of size 2 and both of the elements are equal. For example, this is considered to be a good array, but this is not a good array, right? Or any array where the elements are not equal is considered not a good array. Now, there is a second condition. The second condition is there can be three elements also, but all the three elements have to be same, right? So this will also be considered as a good subarray. Now, there is one more condition. The subarray has to be of the size 3 and all the elements have to be consecutive. That is, this will be considered a good subarray. And it has to be in the increasing order, right? Just because it is consecutive doesn't mean it has to be 3, 5, 4. No, this is not considered a good subarray. Or 7, 6, 5. This will not also be considered as a good subarray. So there are three conditions. One is both the elements have to be equal, or three elements have to be equal, or the elements have to be consecutive. That is, the difference between each of them is just one and they are in the increasing order. Now let's look at few examples to understand this. This is the first array. Now can we divide this in such a way that all of them will be good? Yes. So this will be one good subarray and this will also be the other good subarray. So yes, we can do the partition. Now let's take this example. Can we divide it in such a way that there will be two good partitions? No, right? We can do this part or this part. But the thing is, you cannot have overlapping arrays. There should be two different partitions in an array. So this example, this is not a valid partition. Now once again, though we can divide this to this won't be a valid subarray, and similarly if we take this three elements, this also won't be a valid subarray. So this is not a valid partition.
Sorry for the interruption, but I have a very quick announcement that we are conducting a binary search workshop on August 13, and in this workshop we will be discussing from the fundamentals of binary search to very advanced level in binary search. Not only we will be discussing problems, but more importantly, we'll be discussing about problem patterns that get asked infrequently in interviews. So if you are someone who is interested in this workshop, I have mentioned the link in the description. Do consider joining the workshop.
Now let's look at the quick observation and the approach that we can follow to solve this problem. Let's look how our brain is solving this problem, right? Now let's look at, see, this is valid. This is valid. So what our brain does is it will remove this part and let's look at just this part. 1, 1, 2, 3. Now is this a valid partition? All we have to check is, since this is valid, we can remove this part, and what we have to do, we have to just check this part. Now to check this part, if this is valid, let's look at the last index. There is the first condition, that is these two elements have to be equal. Are they equal? No. The second condition, all the three have to be equal. That is also not true. Then there is the third condition where by all the three elements have to be consecutive. Are they consecutive? Yes, they are consecutive. So now this also forms a valid partition. The next thing, all we have to look is this part. All we have to look at is this part. Now is this a valid partition? Yes. So the entire array will now become a valid partition. So what did we do? We removed a valid partition. And checked if the remaining array is a valid partition or not. So there was a main problem, and each step we identified a valid partition and the main problem got reduced to a sub problem. That is, the size of the array got reduced. But let me tell a catch. Now this is not the only valid partition, right? 4, 4 is also a valid sequence. So now this can also be split as 1, 1, 1, 2, 3, 4. Now let's look at if this is a valid thing. How to check if this is valid? We have to consider the last index. Once we are considering the last index, we will look at 3. No, not the equal, but 2, 3, 4 are consecutive to each other. Now this is a valid. Now all we have to do is check if this is valid. Since this is also valid and this is also valid, the entire problem is valid. So there are two options that we saw of how we can split the array. Now what we will be doing, the idea is same, that we will be splitting the problem or reducing the problem size at every step. How do we do this? Now let's start from the beginning. Let's take the same example, 1 1 1 2 3 4, and we have this, right? So what we'll be doing, let's say we'll be starting from this index, and is this a valid sequence? If this is a valid sequence, we will say true, this is a valid sequence. Now once we go here, there is a condition that all the three elements can be equal, so this will also be a valid sequence. Now let's start from 2. Now all the three condition will fail here, so this should be marked as a false, which means this array will never form a valid sequence, right? So what are we doing? At every index there are three cases. One is if the previous element is equal, the condition is this array has to be a valid array. And how do we do that? We know that, right? We are marking from the left side to the right side. So whenever we are at an index, we can just check if I minus 2 is valid, this is valid. If it is valid and these are also consecutive, that is the first case. What is the second case? The second case is three consecutive elements are equal, and once these are equal, we have to check if this array is true or false. That is the second case. What is the third case? The third case is which we just saw, that is three elements are consecutive to each other and I minus 2 is also a valid array. Now let's look at an example to understand this. Let me erase all of these values and start filling it from the beginning. Okay, now is this a valid 1 1? I have marked this as 0 and I have taken 0 as a true. Why? Because that will be easier for the problem. Now let's look at just this index. Now for this index to be true, what it will do? It will check if they are consecutive elements, or if the elements are equal. Are the elements equal? Yes, the elements are equal. And also at 0, since we have a true, this can also be marked as true. Now again, can this be marked as true? Yes. Why? Because there are three consecutive elements. So this can also be marked true, but under the second condition. Now let's look at this. What are the two conditions? The first two condition fail and the third condition also fails, so this can be marked as false. Now again, this can be marked as true. Why? Because it will check the three consecutive elements, and since all of them are same, it will check this value, and since that is true, it will mark as true. Now again, for this 4, it will look at these three consecutive elements, 2 3 4 are consecutive, and it will look at this value, so this can also be marked as true. Similarly, this can also be marked as, can this be marked as true? Once again, let's look at, yes, this can also be marked as true. That is these two consecutive elements, and we will check this value, and that is true. So this can also be marked true, and finally true. So we will be returning this value. Alright. Now let's look at a false example. Now, can this be marked as true? No, this can't be. Can this be marked as true? No. None of the conditions. This will match a condition, so this can be marked as true. But for this to be valid, we have to check I minus 2. That is this value. Is it true? No. Since that is false, this can be marked as false. And our total answer is a false. So this is not a valid scenario. Now let's dive into the pseudocode and let's understand what is there in the pseudocode. First of all, we create a DP of size n plus 1 and we mark the DP of 0 as true. This is our base condition. Now what we will be doing, this is the first scenario, that is if the first two elements are equal, we can mark DP of 2 is equal to true. Why I am doing this? Because at every step we need not check the same thing. Now what we will be doing, we will be starting from the second index, and there are three conditions, the first, second and the third condition. The first condition is pretty clear, the second condition, the third condition we are checking, and this index is adjusted accordingly. Why? Because since we had an extra index, we are adding 1 here, and similarly we are doing, instead of I minus 2, I minus 1, instead of I minus 3, here it is I minus 2. Right. Finally, we will be returning DP of n. And there are a few similar problems that you can consider solving to understand these problems. And we have a dedicated Telegram group to discuss about this problem. So do consider joining the Telegram group. I have mentioned the link in the description. Thank you for watching the video. Please do like, share and subscribe.